And that wraps up measures of spread. So we've covered center, shape, and spread. Again, those will be very key later on. So remember, every time we have a data set, we have a distribution, we can talk about those three measures. For right now, what we're left with is that we can work with a mean. The downside to it is that it is not robust or resistant, but it's very commonly used. A median would be better. It just doesn't have the good mathematical properties. When we talk about shape of a distribution, we can call it symmetric, we can call it right skewed, we can call it left skewed. And then we can also find the standard deviation to give us a good measure of how far apart all of the points are. The last thing I want to do is come back to section 2.3, that measures of location. And we're going to talk about first percentiles, something you've probably seen before. Percentile is the value such that a certain percent of the data values are less than it. And you've probably seen this when you took maybe a standardized test like the SAT, the ACT, probably told you what percentile you were. And so if you were in the 57th percentile, what that means is that 57% of people were less than you in that score. If you're the 83rd percentile, that means 83% of people were less than that score. And so a percentile is just a value that says that's the percentage of scores or people or tree heights, again, whatever it may be, that's less than that to the left of if we were to draw it out on a picture. We have a similar idea with quartiles. Quartiles are the values that divide the set into quarters. So if I were to say to take 4 quarters, I need 3 dividing points. Make sure you catch that if we have 4 quarters, because quartile means 4, there are only 3 quartiles because there are 3 values that cut my data set into 4 pieces. If you watch basketball, watch football, think about there are 4 quarters in those games, but in those games there are only 3 quarter breaks, right? There's the quarter break between the first and second quarter, and there's halftime between the second and third, and there's the quarter break between the third and the fourth quarter. So there's only 3 values that separate us into 4 different quarters. And then our last definition for this chapter is a z-score, or a standardized value. These are synonymous terms. Make sure you know that standardized value and z-score mean the same thing. It is a unitless measure of location that explains how extreme a data point is relative to the mean. And there's more to this definition, but I'm pausing right here. So I want to talk about this part of the definition before we get going further, because it's kind of long. We have a formula at the end. So it's unitless. So that's a key thing to remember. A mean, a median, a mode will all have units equal to the data set, right? So if we're, a data set of apples, the mean is that many apples, right? If I say I have one person has 5 apples, one person has 6 apples, one person has 4 apples, I would say the average is 5 apples, right? So mean, median, mode all have the same units as the data set. We talked about standard deviation has the same units. That's what makes it make sense. Variance has units squared. That's what makes it not make sense. A z-score has no unit. Okay, so when we have z-scores, you don't add units to it. It's a unitless measure, and it explains how extreme a data point is relative to the mean. Okay, so basically, how extreme are you? So if a z-score that is large, and I mean large in the absolute value sense, -5 would be very large as well. 5 would be very large. It's all relative to the mean. A z-score of 0.2 or 0.8 means you're not very far away from the mean, right? It's all about how relatively far away you are from the mean. And another way to think about it, maybe the way I like the most, it makes it make the most sense to me, is what we're going to write next. So maybe that first part you're like, okay, I guess. But this one might really hammer it home. It's how many standard deviations above or below the mean a data point is. So if you were to say you have a z-score of 1.5, that means quite literally that value is 1.5 standard deviations above the mean. If you have a value that has a z-score of -2.2, that means that value is 2.2 standard deviations below the mean. And we find it by this simple formula, and I'm going to write it in 2 different ways, but really what I want you to focus on is this. I'm probably going to say this a lot, so you'll get tired of hearing me say it, but we find a z-score. We standardize value by taking a value, subtracting its mean, and dividing by its standard deviation. If you remember that concept, it'll serve you well. I'm going to write out both ways we can do that today, but as we move forward, there will be lots of ways we can do that. And so if you just remember this general concept, you'll be covered no matter what, and you'll be able to keep it all straight. Value minus mean, divide by standard deviation. And so what that means is we can find a z-score by taking a value, an individual x, subtracting its mean, sample mean x bar, and dividing by s, the sample standard deviation, value minus mean divided by standard deviation. Or if you're dealing with population data, you would do the same thing, value minus mean divided by standard deviation, but my symbols are different. Now it'd be x minus mu over sigma, because this would be a population mean, this would be a population standard deviation. So again, we standardize a value by saying, what's that value? We subtract its mean, we divide by its standard deviation, and that gets us to a z-score.